Hello and welcome dear students. Today we are going to discuss about the topic scientific developments and practical treatises. This lecture aims to understand the developments made in the scientific and technological sectors in the ancient India. The contribution of great Indian scientists like Aryabhatta, Varamehra, Nagarjuna, etc. on science, medicine, astronomy, astrology, numerology and other branches of knowledge will also be studied. Learning outcome. After the completion of this module, one would get a holistic picture of scientific developments in ancient India. This lecture will help to explore the areas like medicine, astronomy, astrology, numerology and other allied fields as well. Dear students, let's first talk about the introductory part about the topic. Science and technology have been critical in the evolution of human society. Humans have had an insatiable desire to watch and comprehend nature in order to command and manipulate it for their own advantage and welfare since prehistoric times. Indians, like people in other parts of the world, have a rich tradition of scientific ideas. A desire to understand the unknown, along with experimentation and observation, has always produced a scientific temperament. This has led to the idea that truth may be found in the real world, with all of its diversity and complexities. Scientists have had the obligation of unraveling the mystery behind the truth and utilizing available resources for the advancement of the civilization. In this lecture, we will learn about the ongoing quest for the knowledge and truth that led to discoveries, inventions and their implementation in day-to-day living in India. Early India is fascinating because of the quantity, caliber and variety of knowledge it produced. The ancient Indians appear to have been good at systematizing, detailing and thinking through everything they knew. They wrote treatises and manuals known as Shastras on virtually every branch of human knowledge: astronomy, logic, mathematics, grammar, phonetics, painting, sculpture, architecture, poetry, drama, philosophy, statecraft, medicine, amatory and so on. Let's have a look at some of these developments in this lecture. The dates for these texts are imprecise and vague, as is with most of early Indian literature. However, it is worth noting that practical treatises document theories and methods that must have been evolving for at least 200 years before they could be codified or written down. The time to which the ideas or practices belong is consequently still wider than the centuries to which the writing of the treatise is attributed. Linguistic writings were among the earliest Shastras for the early historic period. Panini's Ashtadhyay or 8 chapters, written about the 5th century BCE, is a foundational work of Sanskrit grammar that systematized the language into what is now known as classical Sanskrit, which differed greatly from old Vedic Sanskrit. All of these writing, both creative and scientific, written after Panini, employs this language based on his grammar. India has a rich history of education, science and technology. It has achieved major advances in the field of astronomy, mathematics, geometry, the Ayurvedic medical system and surgery. Geometrical theorems were developed by Indian intellectuals long before Pythagoras in the 6th century BC. An ancient manuscript called Sulva Sutra, which dated from roughly 600 to 300 BC, contains a full exposition of these theorems and axioms. The ancient work Sulva Sutra, which was written between 600 and 300 BC, contains a thorough explanation of these axioms and theorems. In the Vedic era, these sutras were employed to create elaborate altars for worship. In addition, Sulva Sutra discusses how to conduct geometrical figures, combine and change areas, measure areas and volume, square, circles and vice versa. Create identical forms with different areas and a myriad of other related issues. Numerous examples of addition, subtraction, multiplication, division and squaring of fractions may be found in Sulva Sutra. In Sulva Sutras, there are also quadratic equations, indeterminate equations, permutations and combinations. In the 2nd century BCE, Jamini's Mimamsa Sutra of Mimamsa school emphasized Vedic ritual as the embodiment of dharma and the road to redemption. Bhadrayana wrote Brahma Sutra, again the Vedantic text, at approximately the same time. It is a significant text of the early school of Vedanta which aimed at investigating into the nature of Brahman, the universal spirit, and Atman, that's individual soul. Kannada's Vaishishka Sutra of the Vaishishka school, published between the 2nd and the 1st century BCE, is an exposition of pluralistic realism which implies that it aimed at identifying and describing the unique Vishesha characteristics of the various objects that exist in the world. This school developed an atom theory that is still used in modern physics today. In the 1st century CE, Gautama's Nyaya Sutra of Nyaya school established the guidelines for a formal sequential approach to logic and reasoning. The Sankhya Karika of Ishvara Krishna of Sankhya school dated to the 4th and 5th century CE, but the philosophy is much older and is based on the idea of Purusha, that's soul, and Prakriti, that's matter, whose union creates the universe and whose separation results in the attainment of liberation for the soul. A manual of yogic philosophy and practice is called the Yoga Sutra, which is attributed to Patanjali. They recommended a number of physical and mental exercises to accomplish cessation of mental activities, Chitta Vritti Nirodha, which would lead to tranquility and release. The Kama Sutra of Vatsayana, which deals with a completely different subject, was written somewhere in the 3rd or 4th century CE. Although it is generally acclaimed and the first work on sexual pleasure, Kama, it actually comes from a far older tradition of erotica. Vatsayana himself lists a number of other experts on the subject who came before him and with whom he frequently differs. Their writings have not survived, unfortunately. While the Kama Sutra does cover sex, it does not do so in isolation. Instead, it views Kama as one of the 3 purposes of human existence, Purusharthas, just as the Arthashastra and the Dharma Shastras deal with the other 2 goals. It shows the pursuit of sex not as a natural desire but as a component of sophisticated urban society where sexual knowledge is an art. Among the intellectual and scholarly luminaries are Bodhayana, Aryabhatta, Brahma Gupta, Bhaskaracharya, Varahamihira and Naga Arjuna. Presented below are the details regarding them. Dear students, let's discuss the Bodhayana, 500 CE. The book Bodhayana Sutra is a work that covers a wide range of topics including philosophical talks on dharma or righteous behavior, ceremonies and as well as scientific discussions on mathematics and so on. Following the Yajurveda school of thought, Bodhayana is credited with composing one of the first Sulva Sutras, appendixes to the Vedas that served as manual enunciating instructions for the construction of Vedic altars, preparation of the spot where Vedic sacrifice were to be performed and so on. It specifically deals with the size of Vedic brick fire altars. From a mathematical standpoint, the building principles are noteworthy. They shed light on a number of fundamental mathematical equations, including the precise value of pi and a variation of the Pythagorean theorem. Bodhayana sequences were named after the sequences linked with basic Pythagorean triples. Dear students, let's talk about Aryabhatta 476 to 550 CE. Among the celebrated astronomers and mathematicians of ancient India, Aryabhatta was first. At the age of 23, he wrote the Aryabhattiya, Aryabhatiyam and the Arya Siddhanta in 499 CE, a lost literary piece on astronomical computations. He attended school at Pataliputra, Kusumapura. The Nalanda University existed in Pataliputra at the period and had an astronomical observatory. Therefore, it is speculated that he may have also been the head of that university. It is reported that he was the head of an institution, Kulapa, at Kusumapura. His most famous work, Aryabhattiya, a book on mathematics and astronomy, has endured to the present day and has been heavily referenced and quoted in later mathematical literature throughout India. Algebra, mathematics, and plane and spherical trigonometry are also covered in the math portions. Additionally, they offer a helpful science table and explain complicated mathematical formulas on continuous and quadratic equations, sums of power series, etc. In the writings of his contemporaries, Varahamihira, and later mathematicians and commentators like Brahma Gupta and Bhaskaracharya, we catch traces of the Arya Siddhanta. Al-Nanaf is a third of his work that has survived in its Arabic translation. Although it is stated that he adopted it from a Sanskrit work, the Sanskrit name of the original piece is unknown. In his chronicles, the Persian scholar Abu Rayhan al-Biruni makes reference to it. Aryabhatta had a significant impact on Indian astrological heritage and the cultures of our neighbors who translated his writings. During the Islamic Golden Age, about 820 CE, the Arabic translation was very important. Al-Khwarizmi and others in the 10th century CE cited some of his justifications. The followers of Aryabhatta, according to al-Biruni, thought the earth rotated on its axis. His explanations of sine Jaya, cosine Kojya, versine Utkarma Jaya, and inverse sine Utkarmija, Jaya Kojya, Utkarma Jaya, and Utkram Jaya had an impact on the development of trigonometry. Aryabhatta and his disciples introduced calendric calculations, which have been continuously used in India for the practical reasons of creating the Panchagam, Hindu calendar. They served as the foundation for the Jalali calendar, which was created in 1073 CE by a group of astronomers including Umar Khayyam in Islamic cultures. The current national calendars used in Iran and Afghanistan are modified variants of Jalaliya. Like the Aryabhattiya and previous Siddhanta calendars, the Jalali calendar bases its date on real solar transit. To calculate dates on this type of calendar, an ephemeric is required. Even though the dates were challenging to interpret, the Jalali calendar had significantly less seasonal mistakes than the Gregorian calendar. In honor of this outstanding Indian scientist, the lunar crater Aryabhatta and the country's first satellite Aryabhattan were given their names. Aryabhatta Research Institute of Observational Sciences, a facility for training and research in astrophysics, astronomy and atmospheric sciences, was also established in his honor close to Nainital, Uttarakhand. He was given the name of a bacterium species that ISRO scientists identified in 2009. Dear students, let's now talk about the Brahma Gupta. The contribution made by Brahma Gupta occupies a special place in Indian mathematical history. Mathematicians today are in awe of his groundbreaking interpretations of geometry and number theory for their creativity. His groundbreaking theorems allowed for the calculation of a triangle's circumradius, the diagonal lengths of a cyclic quadrilateral, the creation of a rational cyclic quadrilateral, and integer solutions to a single second-degree equation. There was a sudden decline in mathematical and scientific inquiries and investigations during the following millennium until the age of Renaissance in Europe, when the Greeks rose to supremacy in mathematics, particularly in geometry, during the period from the 7th century BCE to the 2nd century CE. However, mathematics and astronomy thrived throughout South Asia, particularly in India and the Arab area. There was a continuous interchange of information between the two cultures and later between Europe and the Arabs, who had benefited greatly from Indian scientific temper. The decimal representation of positive integers combined with zero was an exceptional contribution of Indian intellect that eventually traveled to the Western world despite some early resistance and hesitation to accept it. Brahma Gupta is well known for his major work, the Brahma Supata Siddhanta, the idea of the opening of the universe, also known as the Siddhanta. The Siddhanta is made up of 1008 shlokas or verses divided into 25 chapters, each of which contains theorization and inference on algebra, arithmetic, geometry, and number theory. He was the first to use the number 0 as a digit. Sindhid is the Arabic translation of the Siddhanta. He is also attributed with another piece, Khandak Hadyaka, which he authored later. The Khandak Hadyaka is a collection of 194 verses organized into 9 chapters that shed light on astronomical calculations. He was undoubtedly a notable mathematician of his time who had the audacity to criticize his predecessors for their flaws and omissions and to correct them to best of his ability. Besides, he wrote sequel to Khandak Hadyaka that corrected some of the notions described in the Khandak Hadyaka. He was also the director of the Ujjain Observatory. Dear students, let's now talk about the Bhaskaracharya. The period between CE 500 and 1200 CE was the most prosperous for Indian astronomy due to brilliant astronomers such as Aryabhatta, Varamihara, Brahma Gupta, Bhaskaracharya and others. Bhaskaracharya's Siddhanta Shiromani is regarded as the pinnacle of all astronomical treatises written in those 700 years or more. It encapsulates the essence of Indian astronomy and mathematics. He authored it at the age of 36 around 1150 CE. He lived in Vijayadavid, surrounded by Sahadri hills. It was an important center of learning during his time. Unfortunately, we have no idea where Vijayadavid was found today. Siddhanta Shiromani is a massive text that contains almost 1450 verses and is broken up into 4 sections: Leelavati, Bija Ganita, Ganita Daya, Gola Daya. In actuality, each of these sections may be considered a unique book. The fact that Siddhanta Shiromani offers straightforward mathematical and astronomical calculating techniques is one of its most significant characteristics. By simply reading through this collection, one can gain a fundamental and important understanding of ancient Indian astronomy. This makes it superior to all earlier astronomical treatises written in India. Its Leelavati part is a great illustration of how poetic language can be used to explain a challenging subject like mathematics. Worldwide, Leelavati has been translated into a number of languages. The conclusions drawn by Bhaskaracharya, including the following: Earth has a power of attraction, is not flat, and lacks all sports. The Earth's north and south poles alternate 6 months of daylight and 6 months of darkness. 15 Earth days are equal to 1 lunar day and 1 lunar night. The Earth's atmosphere extended to 96 kilometers. There is a vacuum beyond the atmosphere of the Earth. He was aware of the equinoxes' precision. He made precise calculations for the apparent Sun, Mercury, Venus and Mars orbital periods. The orbital periods he determined for Jupiter and Saturn deviate slightly from the equivalent contemporary values. His techniques and theories are still applicable today. Dear students, let's now talk about Varahamihira, 505 to 587 CE. Varahamihira belonged to the group of Indian scientists that include Aryabhatta, Dhanvantari, Shushrut, Charak and Bhaskaracharya. Their fields of competence ranged from meteorology to mathematics to surgery to medicine. He had learned a remarkable amount about a wide range of technical topics, including hydrology, meteorology, astrology, astronomy, and seismology. The Brihata Samhita, his crowning achievement, sheds light on all these. His work, the Brihat Jataka, was translated into Arabic by the Arabic scholar Al-Biruni. Additionally, he praised Varamihira for the Brihata Samhita's exquisite detail. Ujjaini was home to Varahamihira. He valued education wherever it was found and was well versed in Greek astrological literature, to which he makes reference in his writing. Yatra Panch Siddhantika, Vivaha Patala and Laghu Jataka are some of his other compositions. He was born to astronomer Aditya Dasa in Avanti, which closely corresponds to modern-day Malwa. In one of his own compositions, he mentions receiving his education at Kapithaka. According to Mandusar pillar inscription, he was one of the 9 gems, Navratnas, of the court of the fabled monarch Yashodharman Vikramaditya of Malwa, who belonged to Olikara dynasty and ruled over most of the Indian subcontinent between 530 and 540 CE. The Panch Siddhantika, written by Varahamihira in 575 CE, is the first work to mention that the Ayanamsa, Ayanabhaga, precession of the equinoxes lasted for 50.32 seconds. It's a book on mathematical astronomy. It outlines the 5 astronomical canons that were in use at the time and offers helpful details on earlier lost Indian writings on the subject. 5 prior astronomical texts are summarized, including Surya Siddhanta, Romaka Siddhanta, Polisa Siddhantaka, Vashishta Siddhanta, Pethamaha Siddhanta. It is an important book on Hellenistic astronomy and Vedanga Jyotisha that incorporates Greek, Roman and Egyptian themes. Varahamihira's hypothesis served as the foundation for Al-Biruni's explanation of the 5 astrological traditions. The encyclopedic Brihata Samhita, another significant contribution from Varahamihira, covers a wide range of interesting subjects including astronomy and astrology, planetary movements, eclipses and their effects, other natural phenomena, geography, botany, clouds, rainfall, the growth of crops, the production of perfume and cosmetics, domestic relationships and matrimony, architecture, iconography, as well as gems and pearls. He also practiced astrology. He discussed the 3 main facets of Jyotisha, that's astrology, including horoscopy. The Brihata Jataka, one of his 5 major works on Hindu astrology, is highly regarded. Dear students, let's now talk about the Naga Arjuna. He practiced both alchemy and chemistry. During the Tantric era, the emergence and development of the scientific field of chemistry in India and especially alchemy reached an exciting phase. It was first centered on the worship of Shiva and Parvati and was a combination of alchemical procedures and horrific rituals. Another category of tantras included a fusion of Shiva and Buddhist cults. This group includes Nagarjuna's Rasa Ratnakara, a significant literary work on alchemy written during the 7th and 8th century CE. It discusses how to make rasa, that's liquid mainly mercury, alchemical procedures and mercurial compound formulations are described in the Rasa Ratnakara. It also provides important details on the extraction of copper, mercury and zinc. He describes how to make crystalline red mercury sulfide, Swarna Sinduraro Makar Davaja, a treatment that is useful and efficient for a variety of illness and problems. He was a distinguished scientist who proposed zinc production by a distillation method in addition to cementation methods for the first time. He also provides a list of the tools that prior alchemists employed in the Rasaratnakara. Distillation, liquefaction and other. According to Al-Biruni, Nagarjuna was a native of the Daihak fort near Somnath and lived approximately a century before him. He is praised for his mastery of the Rasayana. The goal of Nagarjuna's endeavors was to turn base metals into gold. His Rasaratnakara takes the form of a conversation with the gods. In this treatise, he has discussed several liquid mixtures. It also examines the state of metallurgy and alchemy at that period in India. Additionally, techniques for the purification and extraction of metals like gold, silver, copper and tin from their ores are being developed. In addition to using minerals and alkalis, he also employed vegetable and animal ingredients to make the elixir of life from mercury. He emphasized the use of vegetable acids for the breakdown of diamonds, pearls and metals such as sour, gruel, fruit juices and bark juice. His achievements as an alchemist, metallurgist, chemist and medicine man are revered by historians. His writings comprise Rasaratnakara, Rasa Rudaya, Rasendra Mangal, Arogaya Manjari, Kaksha Putatantra, Yogasara. Despite the fact that Nagarjuna was unable to make gold through the transmutation of base metal, his techniques did yield metal with gold-like characteristics such as yellow shine and yellowish brilliance. Even today, same methods are used to create fake jewelry. Dear students, let's now talk about the Charaka. Sushruta Samhita, the surgical classical and Charaka Samhita, the fundamental Indian treatise on medicine, were written between the 2nd and 5th century CE, represent the ancient Indian system of medicine. Ayurveda, knowledge of long life, which continues to thrive today. They establish a holistic approach to human and even animal physiology, disease and therapy with astounding knowledge and accuracy. The texts cover a wide range of disorders, their causes, symptoms, diagnosis and treatments, including medication and surgery. They talk about nutrition, epidemics, doctors, hospitals and anatomy, which covers functions like digestion and blood circulation. There are descriptions of stitches, cataract and bladder stone removal and even plastic surgery. Early translations of the two Samhitas into Arabic, Persian and Tibetan allowed Ayurveda to spread to East and West Asia and even into Europe. Dear students, that was all about today's lecture regarding scientific developments and practical treatises. Hope you have understood it well. We shall meet again with a new topic. Till then, take care of yourself and goodbye.